Good morning, students. Sorry, good afternoon. Welcome back to science class on the chapter of electricity. The heating effect of electric current. Okay. Also, we did a Joule's law of heating. That is H is equals to I square into R into T. Okay. So the heat produced the conductor is directly proportional to the square of the current, resistance, and time taken. Okay. Due to the resistance, while flowing, while electrons while flowing through the conductor, due to the collision, what happens? The heat is created in the conductor. Okay. So now in this class, we will discuss practical applications of heating effect of electric current. For example, you have a conductor. Okay. Yes, electrons are passed through this conductor. So now we can use the heat produced with conductor, the heat produced in this conductor for our daily purpose. For example, water heater. Okay, so there we are see, there we are using heat to boil the, then induction cooker, other example iron box. Okay, see here we are increasing that collision, means we are doing that forcibly we are increasing that collision. Why? Here we need heat. For example, if you use your mobile phone for a long time, so the heat is heat is created in that mobile phone. So using that heat, you can't use that heat for your daily purpose. For example, to boil the water and for cooking purpose. Okay, or iron. Here we need more heat. Correct? So here we need more heat. So that's why if we create forcibly, what we should create more heat in the conductor, then we can use that heat for our daily purpose. Okay. For example, already we have discussed, right? Water heater. This coil. It is like this. Okay. So here, see here. This metal, it is made up of alloy. Okay, so here we are using these materials. Why? Just to increase the collision. To increase the collision. Why? Because here we need more heat. Correct. So that's why here we are using what? We are creating more collision. When the collision is more, then resistance increases. Resistance means what? When resistance increases, heat increases, right? So that's why here we are using some materials just to increase the temperature, increase the heat. Okay, so these are made up of what? These coils are made up of alloy. Alloy, right? Alloy is a mixture of two or more metals. Okay, next, in the micro oven, there also we are using, and iron box, there also we are using. Okay, take bulb. Okay, see, nowadays now we are using LED bulbs. Earlier, I think you might have seen this kind of bulb, tungsten bulb, red color. Okay, so here we are using tungsten, even that tungsten. Okay, why? Because see here, first it melts. Okay, not it melts. First it gets heat. It gets heat, then emits light. See, this action takes place within a fraction of a second. First, it gets heat. Okay, later it emits light. Okay, see, this entire action takes place within a fraction of a second. When you turn that button, you will get the light. Correct? So here the actual process is, first this tungsten, it gets the heat, then later it emits light. Okay. See here, actually, here we are passing electrical energy. Correct? Here we are passing electrical energy. So this bulb which converts electrical energy into light energy plus heat energy. Why? Because when you touch this bulb, you can feel heat, right? Okay, so here this bulb which converts electrical energy into light energy plus heat energy. Here actually, see here only less amount of energy is converted into light energy. The remaining energy is converted into heat energy. Here, for example, here efficiency we will get only 10 to 15%. Okay, then the remaining 85% or 80%, which is converted into heat energy. Okay. Uh, Next, and one more thing, see here in water heater, okay, and a micro oven in bulb. Here we are using materials. These materials they have high melting point. What? They have high melting point. Okay, here this bulb tungsten, it has high melting point, and this coil, okay, this has high melting point. Why? Because see here we are using high melting materials. Why? Because just to hold the temperature, just to hold the heat. Instead of these coils, if we use normal aluminum copper, what will happen? They will burn, right? Due to the heavy heat, they will burn. Okay, so that's why here we are use alloy. Why? Because alloys, they have high melting point. They do not oxidize or they do not burn at easily. They do not burn easily or they do not burn at a quick temperature. Are you getting my point? Okay, they do not oxidize or they do not burn easily. Okay, so that's why alloys are used in coils, and the tungsten we use in the bulb and the microwave iron box just to hold the heat. Okay, and see, which one, and we use what tungsten to make the bulbs. Okay, and also here inside this bulb we use some gases. Okay, one we use tungsten. Why we use tungsten? Because tungsten, it has high melting point. And second one, here we use some inactive nitrogen and argon gases. Okay, here we use inactive nitrogen and argon gases. Why? Because to prolong the life of the filament, or prolong means to extend the life of the filament. Okay, so here we are using nitrogen or argon gas. Why? Just to increase the life of the filament. Correct? See, if you say I manufacture one bulb, if it works only for one day, it will last for us, right? So we need long durability. So that's why here we use nitrogen gas and argon gas. Why? Just to extend the life of the filament. Okay, which means we should use this bulb for a long time, minimum 2 months or 3 months or 4 months. Okay, so why we use the nitrogen argon gases? Just to extend or prolong the life of the filament. And here we are using tungsten. Why? Because the tungsten, it has high melting point. Okay, it do not oxidize easily or quickly. Yes, already we discussed here. See, here only most of the part which is converted into heat energy, only less amount which is converted into light energy. Okay, if you take a fan, okay, that fan is rotating, right? So it is in motion. So here that fan which converts electrical energy into kinetic energy plus heat energy, because when you touch that fan, you can feel heat. Okay, next, and one more common application, we use this Joule's heating in fuse. Okay, I think you might have heard this word, fuse. We have seen. Okay, fuse. See here this fuse is also made up of alloy. Okay, this fuse is made up of alloy. See, we use this fuse for safety purpose. Okay, for safety purpose. For example, see, this is your home. Okay, so we'll get the connection of electric energy from the outside. Okay, so here before supplying that electric connection to your home, here first we will connect that to the we will discuss in the magnetic chapter. Okay, here these two are neutral and phase. Okay, this phase wire is connected to fuse. That fuse is connected to phase. Why? Because see here this is also made up of alloy. For example, to run in homes and buildings, to run all the equipments, we need maximum 220 to 230 voltage. 230 voltage. Okay, suppose if the supply voltage is excessive, for example, say by mistake, okay, the 500 voltage I passed through, what will happen? So all the devices burn. Clear? So that's why to avoid that one, we are using fuse. Why? Because here it is manufactured just to operate at 230 or 220, 230 or 240 voltage. Suppose if the voltage is say 300, at that time what will happen? Okay, so it will melt and which breaks the circuit. Clear? If you pass excess voltage, what will happen? This fuse here, this wire, okay, it melts and it breaks the circuit, which means there is no connection between this main line and your home. Okay, for example, you have one bulb and here you have connected one battery. Okay, negative. So now tell me what will happen. See, I'll break here. What will happen? It won't blink, right? Why? Because there is no connection here and here. So here also same. If the voltage excess, if the voltage is very excess, say 300 or 400 or 350 like that, so then this fuse it melts. Okay, it melts and which breaks the circuit. So that's why for safety purpose we are using fuse. Okay. Next one. See, remember, keep in your mind, always we place this fuse in a series. What is that? In series. If you keep, for example, see here, you have 3 bulbs. See here. Now, first I will connect one small fuse here. I will connect one small fuse here. Now what? See, for example, these bulbs they need just 2 voltage. They need 2 voltage. I pass a 10 voltage. What will happen? They'll burn, right? So now here I have connected fuse. What will happen? See, this fuse it operates or it works at 2 voltage. If the voltage is very excessive at that time, what will happen? It melts and which breaks the circuit. Which means there is no passing of electrons to this bulb. Correct? Why? Because here I have used in a series. Suppose I will use the fuse here. I will use here. What will happen? It breaks the circuit here. Okay, if you pass excess voltage, which breaks here, there is no electricity, there is no voltage passes through this bulb. But what about these two? Passes, right? Okay, so these two will burn. So that's why if you connect that, if you connect that fuse in parallel, so that's why always we should connect that fuse in series. So 4 ampere, 5 ampere. Okay, see, for your 250 to 230 voltage, for this one you can't use 1 ampere. Okay, you can't use 1 ampere fuse. Why? Because to run the appliance they need minimum 250 voltage. If you pass 250 or 220 voltage, it will burn. Okay, it will break the circuit. Okay, so according to the value and power of the circuit will decide the value of the fuse. For example, say take iron, which consumes 1 kilowatt hour. The power of that iron is 1 kilowatt hour. We'll discuss that what is 1 kilowatt hour. Okay, so 1 kilowatt hour at it operated at 230 voltage, 220 voltage. Okay. Yes, here you are passing 220 voltage to one iron and it will consume energy in 1 kilowatt hour. Okay, for this one here we need 4.5 ampere fuse. 4.5 ampere fuse. Now how to calculate that one? See, the energy consumed by iron. What is that? That is 1 kilowatt hour, right? So 1 kilo means what? 1000 divided by what is the voltage? 220. Cancel. So here you will get 4.5 ampere. Okay. See, that iron which is consuming 1 kilowatt energy. Okay, 1 kilowatt hour or 1 kilowatt. We discussed that what is 1 kilowatt, what is the meaning. Okay, so at voltage 220 voltage, then that iron it requires 4.5 ampere. Okay, means see you are passing 220 voltage to that iron. If you pass 250 voltage, or say if you pass 300 voltage, what will happen? It melts. Okay, which gives safety to that iron. Okay, which breaks the circuit, means which breaks the excessive voltage. Suppose instead of 4.5, if you use 2 ampere, 2 ampere fuse, what will happen? It melts. Correct? So that's why for that iron, it consumes energy 1 kilowatt hour and it operates at 220 voltage. For that, we need 4.5 ampere fuse. Okay? Yes, sir. Next, we move to electrical power. Yes, already know, right? What is power? So, power means work done in a given time. So in the previous class, we got this expression. So P is equals to V into I. Okay. When you multiply voltage and current, you will get the power. So now we can rewrite this formula as, see here we can V equal to what? I into R, right? Into I. That is I square into R. Next, or one more, to V into V by R. We can write V square divided by R. To calculate power, we can use these three formulas. Okay, so we can use either V into I or I square into R or V square by R. Okay. Here, the rate at which energy is dissipated or consumed in an electric circuit. This is also termed as electric power. Okay, electric power means how much energy is dissipated in the circuit. That dissipated energy we can calculate using these formulas: V into I square into R or V square by R. Okay. Next, so you know SI unit of what is SI unit of power? That is watt. Okay, SI unit of power is watt. Then now tell me what is the meaning of 1 watt? 1, see that is capital W. If 1 joule of work is done, we know the one more formula, that is work done divided by time. If 1 joule of work is done in 1 second, then we can say that power of that object is 1 watt. But here power equal to V into I, right? Okay, then what is the meaning of 1 watt? The meaning of 1 watt, that is 1 volt into 1 ampere, means, see, if you pass 1 voltage current, sorry, if you pass 1 voltage, 1 volt voltage, then the current through this bulb is 1 ampere. So now we can say that the energy consuming by this bulb is 1 watt. Okay, now clear what is 1 kilowatt? 1 kilowatt. What is the meaning of 1 kilowatt? Yes, 1000 watt means what is the meaning? 1 watt means 1 volt in 1 volt and through 1 ampere current. Okay, then what is the meaning of 1 kilowatt? What is the meaning? We can define, right, 1000 voltage in 1 ampere, or see, it's not a problem, we can't for 1000 voltage we can't use 1 ampere. Okay, or we can say what 250 voltage into 4 ampere, correct? We can say that 1 kilowatt. Okay, so clear, right? What is 1 watt? So in exam they'll ask to define 1 watt in an electric circuit. How to define? Yes, if voltage across the conductor is 1 watt and if the current through that conductor is 1 ampere, then we can say that what energy consumed by that the conductor is 1 watt. Okay, so here the SI unit of electric power is watt. It is the power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt. Thus, so 1 watt equal to 1 volt into 1 ampere. Okay. Next, see here, you know, this unit is very small. 1 unit, 1 watt or 2 watt is a very small. Okay, see here we are using a current in home we are using voltage that is a 250 220 230, but in companies there we are using 1000 voltage and in a railway, okay, there we are using 10,000 15,000. At that time we can't use that watt. At that time we use kilowatt. Okay, so what is kilowatt? Kilowatt is equals to 1000 watt. See, in actual practical, we use a much larger unit called kilowatt. We use this one kilowatt. Okay, if the conductor consumes more energy, okay, if it consumes more energy, for example, you have one conductor which consumes 2000 watt. 2000 watt. Instead of writing 2000 watt, we can write in short form that as 2k watt. Here k means what? Kilo. Kilo means 1000. Okay. Yes. So 1 kilowatt is equals to 1000 watt. Okay. Yes. Next. Next one. See here the unit of electrical energy. Okay. Unit of electrical energy. Unit of electrical energy is equal to watt into hour. Unit of electrical energy. You know the formula. P is equals to work done divided by time. Correct? You know this formula. Power equal to work done divided by time. So here work done means what? So now can I say work done equal to electrical energy? In the previous we have studied work done equal to heat energy. So we can say that work done equal to electrical energy. See, energy will that energy is converted to work. You are using energy for what? Just to do work, right? So entire energy will express in terms of work done. So that's why here power equal to work done divided by time. So here work done means what? Electrical energy. We can write this formula as P is equal to electrical energy divided by time. Okay, divided by time. So now bring time this side. Now bring this side. So we can write electrical energy. I'll write here. Electrical energy is equal to power into time. Okay, power into time. So power equal to electrical energy divided by time. So that is electrical energy equal to power into time. So we measure power in watt and time in seconds. Time, but here we are using, right? So that's why we are using hour. Okay. Instead of seconds, here we are using hour. So what is the essence of electrical power? Electrical energy, watt hour. So here work done is equal to electrical energy. Keep in your mind. Okay. So that's why the essence of electrical energy. In exam they will ask in a question, calculate the electrical energy. At that time you have to multiply power and time. Okay. So essence of electrical energy is watt hour. Even this watt hour is also very small. You know, for example, machines. Okay. For example, you are doing one work. So to complete that work, you will take supply voltage is 1 watt and current through that conductor is 1 ampere. So then we can say power of that bulb is 1 watt. Now here, what is 1 watt hour? So electrical energy is 1 watt hour. Then what is the meaning? Quick. Fast. See here, you have one bulb. Okay, you have one bulb, and it consumes energy. It consumes energy. Say 1 watt. It consumes energy 1 watt for 1 hour. For 1 hour. So then we can say that electric energy is 1 watt hour. Okay. If you have a conductor, okay, so power consumed by that conductor is 1 watt for 1 hour. So here it should consumes 1 watt, not only for 1 second, 2 seconds. It should consumes energy for continuous 1 hour. Okay, then we can say electric energy is 1 watt hour. Okay, and this 1 watt hour is very small. For that we use kilowatt hour. Kilowatt hour means what? Okay, 1 kilowatt hour is equals to 1000 watt hour. Now tell me, what is the meaning of 1 kilowatt hour? Yes. So if this bulb, okay, just this bulb, if it consumes 1000 watt energy, if it consumes 1000 watt energy for 1 hour, for 1 hour, so then we can say that electric energy is 1 kilowatt hour. Okay. So 1 kilowatt hour equal to 1000 watt, or we can write here. See, 1 kilowatt hour, we can write this as 1000 watt into hour means what? 3600 seconds. Okay, 3600 seconds. So when you multiply 1000 into 3600, you can write that as 3.6 into 10 raised to the power 6 watt second. 6 watt second. Okay, instead of writing this 1000 watt hour and 3600, you can write like this. So watt into second, what it gives? Watt into second, that is 3.6 into 10 raised to the power 6 joule. Okay, so instead of writing 1 kilowatt hour, so 1 kilowatt hour is equals to, see what is, see this is the SI unit of what? 1 kilowatt hour. It is the SI unit of what? It is the SI unit of what? SI unit of electrical energy. Okay. See, SI unit of electrical energy is watt hour. Instead of, this is very small, right? So that's why we are using kilowatt hour. Okay. So 1 kilowatt hour means, see, what is the SI unit of energy? SI unit of energy, joules, right? So now this is the SI unit of electric energy. So that's why instead of writing 1 kilowatt hour, we can write 3.6 into 10 raised to the power 6 joules. Okay. Here power. Okay, so power P is equals to V into I. The SI unit of power is watt. What is the meaning of 1 watt? 1 watt is equals to 1 volt into 1 ampere. If I ask to define 1 watt, don't write 1 volt into 1 ampere. Okay, they'll ask define 1 watt in an electric circuit. At that time, you can't use this one. 1 joule of work is done in 1 second. Don't write this one. Okay, write this one. Okay, so 1 voltage flow, it carries a 1 volt potential difference of 1 voltage, and 1 ampere current passes through the conductor. Okay, next, if this is watt is small, very small, if the energy consumed is very large, power means what? Energy consumed. Both are same. Energy consumed or power. Okay, if the energy consumed is more, at that time we use kilowatt hour. At that time we use kilowatt hour. Kilowatt hour is 1 equal to 1000 watt. Okay. Next, electrical energy. So power P is equals to work done divided by time. We can write electrical energy divided by time. So then we can write electrical energy is equals to power into time. Okay, so here the SI unit of electrical energy is watt hour. Watt hour. So what is the meaning of 1 watt hour? If a conductor, if it consumes 1 watt energy for 1 hour, so then we can say that electrical energy of the conductor is 1 watt hour. So this watt hour is very small. So that's why we use kilowatt hour. What is that? Kilowatt hour is equals to 1000 watt hour. Okay, so we can write 1 kilowatt hour is equals to 3.6 into 10 raised to the power 6 joules. Okay, why? Because see, the SI unit of energy is joules. Here this kilowatt hour is the SI unit of electrical energy. So that's why we measure SI unit of energy is joules, right? So that's why we can write like this. Okay, and keep in mind, see, this is a general. Many people think that electrons are consumed in an electric circuit. This is wrong. Okay, this is wrong. Many people think that electrons are consumed in an electric circuit. So this is wrong. We pay the electricity board or electric company to provide energy to move electrons through the electric gadgets like electric bulb, fan, and engines. Okay, we pay for the energy that we use. You know, in electricity, we will pay for the bill, right? Actually, here we will comment will say that the energy waste is on that thing. That is wrong. Okay, here we are paying money for what? You know, you will get a connection from outside, right? To your home. Okay, through that wire electrons will come. Okay, see how many electrons will come, that is secondary. Here you are paying, see, to send those electrons. See, to pass electrons we have to use some potential difference, right? So using battery you can pass the electrons from one point to another point. So here you are paying money just for their what? Just to send the electrons. Okay, see, they pass the electrons right through the wire. Okay, for that they are doing work. For that work you are paying money, and that money is electric, what we call electric bill. Okay, to send electrons, how much? See, send means what? You will consume energy. If you consume more energy, which means they have to do more work. So that's why you have to pay more money. Okay, see, keep in your mind what? So here we pay the electricity board or electric company to provide energy to move electrons through the electric gadgets. Okay, so I will stop here. This chapter is complete. Electricity chapter is completed. So tomorrow class we will discuss problems. Okay, thank you.